Yes, yes, it's clear. All right. So thanks, Victory, for this extra session to make up for last week. All right.
Yes.
So yeah. So yeah. So probably you can maybe we can start. Okay. To
Yeah.
just quickly update what you have done since yesterday.
Okay. Sorry, I
Okay.
think that's the wrong window.
Okay.
So, okay. I'm just gonna share my screen.
Yeah. Sure. Thanks.
Where you? Okay, there. Fine. All right.
Okay.
Can you see
Yeah.
my screen?
Yes. Yes.
So I tried to sort of separate, like you suggested, the problem statement for two contexts or two scenarios.
Okay.
The first for positioning and the other
Okay.
one for data, basically.
Right.
That's for the the data storage and data dissemination. So in the first one, I basically started with IoT world. I felt like that was a bit general. I'm not
Okay.
sure. But in the IoT world, there's a major field. Made reference to wireless sensor networks, where major strides have been made in efficiently connecting sensor nodes and transferring location data between nodes. I wasn't sure if I should just specify location data or just say data in general.
Okay.
However, the systems are optimized for static. Wow, not static networks. What am I talking about? I meant static nodes,
Okay.
uh, where the sensor nodes are, in one place. Basically, that's what it means. So
Okay.
in systems where the nodes are dynamic, we're basically constantly moving. It's difficult to sort of maintain connection. There's not a lot of research on that. I did a brief, not very intense check, but a
Okay.
brief check. There was not a lot of information on that. So basically, the idea is we propose a decentralized spatial routing system that provides both static and dynamic movement among the nodes. Like it provides the option while sort of maintaining connection without losing a lot of information while during movement. Yeah.
Okay.
And data from a data context, the idea is I went instead of IoT this time, I just said in the industrial sector. Data acquisition, storage, and dissemination are a big part, of industry. There's always some form of this that's required. So in the future, where systems are automated and remotely managed, basically everything over the internet, there's a need for more storage systems for the acquired data, more bandwidth, or should I say more what do you call it? Because they will be streaming large amounts of data. I'm talking gigabytes and terabytes,
Okay.
and where
Potentially. Yeah.
potentially exactly
Yeah.
and more efficient algorithms to distribute the data.
Okay.
So to counter this requirements on a large scale, we propose a decentralized spatial routing approach.
Okay.
In this approach, the system runs such that the devices can, efficiently manage and distribute spatial data across multiple sensor nodes.
Okay. I see. All right. Okay. So I mean, this is what you've done since yesterday, right?
Yeah. Yeah.
Okay. Okay. All right. Okay. Good. I think it's good that you're pointing out. I think these are the main axes. I think one is dynamic versus static, right? And the
Yeah. Yeah.
other, you also talk about data acquisition, storage, and dissemination. These are different use
Dissemination.
cases.
Yeah.
Yeah.
Yes.
Okay. Okay. All right. But I think this is my feedback. Okay.
Okay.
Yeah, yeah, actually, I think we're still right now focusing on defining the problem. Okay.
Okay.
So that the problem itself, the problem statement can be more clear. Okay. And also,
Okay.
I think simple, easy to understand. Okay.
Okay.
So actually, what you wrote yesterday, that I felt is quite good. Actually, okay.
Oh.
In
Okay.
terms of a user scenario, okay, or how we usually call it, a user story, okay,
Yeah.
in developing software products, it's called the user story or the scenario, right? I think that's a good scenario, but and that actually describes the problem, you see.
Okay.
Okay, so that was more a problem, but I mean, what you've written now, these two paragraphs, they are actually
Yeah.
more now about the potential solution side. Okay, so I think it
Oh,
would be
okay.
good to write them, describe them in the solution sector, which is after we're stating the problems. Okay,
Yeah.
okay, but and you can talk about that. The solution actually has these two axes in terms of one is static versus dynamic nodes, okay, that
Okay.
are
Yeah.
participating in the network. And also the other axis is data collection, or data acquisition collection versus dissemination.
Yeah.
Okay. And obviously storage is, you can sort of put that in between or related to the acquisition part, right?
Yeah.
Or
Yeah.
it's something in the middle. I mean, storage, I think that's another issue that can be discussed. But essentially, I think the other axis is, are you talking about sending data or receiving or collecting data, right?
Yeah.
Okay.
Yeah.
So so the I think going back to the problem, okay.
Yeah.
Actually, the problem part, what I would like to see, or what I was sort of expecting, or would like to see is other scenario descriptions. You see,
Oh.
okay,
Oh.
like
Okay.
other user
Sorry.
stories. Okay,
Okay.
that because what you have described in the smart factory, I think I also mentioned this yesterday, is
Mm.
the scenario is actually static, right? Static
Yeah.
nodes, and it's
Yeah.
more towards data collection, right?
Yeah.
Right,
Yeah.
static data collection, right? So that is just one
Yes.
of the quadrants. You see, if you look at it from these two axes, um, collection this versus dissemination, also dynamic versus static. Okay, if you
Yeah.
sort of draw two lines and make them four quadrants, you can actually categorize different user stories to these one of the four, right?
Okay. Yeah.
Okay, so I actually would like to see is if you can come up with a user story, okay, that is actually in each one of these categories.
Okay.
You see,
Um.
okay,
So.
and the reason, and also sort of just I mean, some of the cases I think we've already encountered, like in agri-tech, right? In the agri-tech
Yeah.
scenarios, it might be data collection, but with dynamic nodes, right?
Yeah. Yeah.
That could be one.
Makes sense.
And
Yeah.
because that's the case when okay, and the other you can think about like okay, like for example like Uber, right? Like a Uber like delivery service, that is
Yeah.
something obviously involving dynamic nodes, right?
Yes.
But
Yes.
also and you can talk about that could be like data collection, right? Data
Yeah.
collection in the you're trying to collect the positions, but also it could be dissemination in terms of trying to get a driver to be interested, right, to
Mm.
basically bid for the rights, right? That
Yeah.
could be
Yeah.
a dissemination scenario.
Yeah. Yeah. Yeah.
And right, and then you have maybe like static and dissemination, and that could be the case where you might want to like reconfigure devices, right?
Okay.
Okay, or maybe like changing the parameters for devices. Okay,
Okay.
so I'm just trying to say that these are actually different scenarios
Okay.
that that could involve like different kind of data communication directions, right? And also
Yeah.
dealing with static or dynamic nodes,
Yeah.
right? Okay.
Yeah.
So I guess the question is, when you have these scenarios, and you want to kind of figure a way, and then it's the decentralized part. Okay. So I mean, the problem could relate to, as as the data size gets large, as the node size gets large,
Yeah.
as the infrastructure support gets lower, like in the rural
Mm,
agriculture scenario, right? There may not be like infrastructure uh, network, right? It could be
okay.
just like a local wireless network. That's when you could run into problems and face challenge with a
Oh,
traditional centralized, approach.
yeah. So,
Okay, does
um,
that make sense?
yeah. So just to, so basically to sort of describe different cases, or should I say different case, should I say different scenarios
Yes, yes,
where
exactly. Yeah,
where we could run into problems and
right, right.
where
Yeah.
so
Okay. So I think well, I think the one thing is obviously, I mean, the one thing is to maybe describe different scenarios first. Okay. And then
okay.
talk about the different kind of the actual the requirements, right? And then it's because okay, so the I think the idea is I mentioned this yesterday as well. When you're just looking at one scenario, right? It's easy to come up with a particular kind of solution, right?
Yeah.
You see, I mean, you
Yeah.
could come up with a specific design that kind of spread the nodes out or spread the devices or try to communicate in a certain way, right? Collecting data,
Yeah.
for example, right? Um,
Yes.
and maybe, having some super pure election algorithm to elect some super pures to collect, and then, like forwarding in some ways, right? I
Yeah.
mean, it's
It makes sense.
easy.
Yeah.
You see, I guess what I'm trying to get at is when you design solution for a particular use case,
Mm,
there are many ways to do it. You see,
okay.
okay, there are many valid
Mm,
ways that you can solve a particular problem. Okay.
yeah.
However,
Yeah.
when you are trying to solve problem at a more general level, okay, let's say you are dealing with not just static nodes, but also dynamically moving nodes, right? And let's say you are
Okay.
not
Yeah.
just dealing with data collection, but also data dissemination,
Yeah.
right? Then it
Yeah.
it kind of becomes a different problem. And I believe what will happen is the solution then will tend to become more general, and
General.
there are
Yeah.
less, kind of there will be less options there now. Okay,
Mm,
because you're trying to come up with something that can deal with all these different scenarios.
true. True.
Is it so far okay,
I
Victor? Are you following?
yes, yes. I am following. I am following. I'm trying
Yeah,
to sort of picture a scenario, or like
right.
I'm trying to think of the words, or should I say the technical words,
Uh-huh.
to sort of describe
Right.
like
It's kind of like I guess what I'm trying to say is, okay, just an analogy. Before World Wide Web, okay, before Triple W was invented, okay, I'm
yeah.
sure there were many different systems,
Okay.
ways for accessing informations, right? I don't know
Yeah.
if you know that before Triple W, there was a system called Gopher. Okay,
Oh
have you heard
wow.
of this? No.
Nope,
Okay,
nope.
that was you can. I mean,
I'll look
there
into it.
were golfers, there were news groups. Okay,
Okay.
news groups.
Yes.
Okay, that
Yeah.
was how
News. Yeah.
people sort of like online forums. Okay, there were emails, right? I mean, all these
Yeah.
different mechanisms, right? Um, and they are more or less and lots of proprietary systems, right? that
Yeah. Yeah.
are that are and proprietary protocols and all that, right? But they
Yeah.
are all trying to deal with basically essentially information access and dissemination, right?
Yeah.
And
Yeah.
how do you access and share information, right?
Yeah.
Over network. But then they are all addressing like specific niche problems. You
Okay.
see, like it
Yeah.
could be like in the case for Gopher, it was actually used widely in libraries. I don't know if you know that.
Mm.
Like you could go to a Gopher server and look for certain informations, like categorize, right?
Yeah.
Categorize information.
Sounds
If you just Google
sounds
Gopher,
okay.
okay, you'll have some description. Okay, but then
Just
Triple W came out,
sorry,
right?
just okay.
Ah, okay, so Triple W was designed specifically with universal information access in mind. You see, you can see from like
Okay. Yeah.
URL, right? URL that was like universal
Yeah.
resource
Yeah.
locator, right? And
Yeah. Yeah.
the HTTP protocol and
Yeah.
all that. Uh, HTML pages. It was
Um.
trying to
Sorry, Shanil.
generalize.
You're breaking up a bit. Hello. Are you still there?
Oh, yeah. Sorry. I mean,
Okay.
there was
It's better now. It's better
yeah.
now.
All right. So I'm trying to say that Triple W came out as actually a more general and also a simpler solution,
Okay.
okay, to the
Yeah.
information access problem. That does that make sense?
Yeah. 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 It makes sense. Yes. It makes sense
Okay.
completely.
So I guess what I'm trying to say
Okay.
is spatial data. Obviously, there has been solutions because there has been problems, right? And this is not a new
Yeah.
problem.
Yeah.
Spatial positional data collection, distribution, routing, right? Routing is another
Yeah.
one. These are all existing problems,
Yeah.
of which there have been different solutions, right?
Yes.
Okay, and I think rather than attacking or solving one, again, a niche problem, what will
Okay.
increase the
General
value,
problem.
exactly, what will increase the value of your work, okay, and of what you're doing is actually try to sort of, take a step back and look at all these problems and ask the question, what are the commonalities of them,
Okay.
right?
Okay.
Okay,
Okay.
and
Yes. I see what
whether
you mean.
you see, and whether there's a way that we can actually, address all these problems, right? The GIS
Okay.
problem, the
Yeah.
Uber problem, the
Okay.
smart factory, sensor data collection, or maybe sending some new configurations to all these devices, right? These problems. Can we actually find a general solution that can accommodate
All the problems. Wow. Actually, I see what you mean. Actually, that makes so okay. So that's why it's actually necessary to sort of see all the test scenarios to sort of write them down. Like as I'm thinking, maybe as many scenarios as possible, maybe 5 to 10, and then just what's the word now? Like put out the test case scenarios, and then to sort of see what's common with everything. Hello. I don't know if you can still hear me. Jeez, what's going on? Uh, just okay.
Hello, Victor, can you hear me? Hello. Hi, Victor. Hello. Can you
Sorry,
hear?
I muted.
Yeah, sorry. Yeah, I think my phone just crashed. Okay.
Oh, jeez, sorry.
Uh, Probably too much bandwidth, too much information. All right.
Ah,
Yeah. So Victor, is that I mean, is it understandable what
it's actually clear. Yeah, I'm actually realizing why you now. I sort of understand why you were actually talking about, writing problems for different case scenarios. So the idea
Mhm.
is when there's like different case scenarios, you can actually read, like, sort of take a step back and look at them from a big picture and sort of identify the common problems with like what's common with
Exactly.
all the. So it's actually be nice to have like a lot of like case
Exactly.
scenarios.
Exactly. Actually, that would be
Oh,
even
okay.
better. Okay.
Oh,
That
okay. Okay.
let's say you can, I think at the minimum, you know, probably come up with some user stories or scenarios that
Okay.
fit, into like a dynamic, basically one of the four quadrants, right? You have dynamic nodes and data collection, or
Yeah.
dynamic data dissemination, right?
Yeah. Okay.
And well, like for example, like just an example, location-based service (LBS). This is going to
Yes.
be big, right? You
Location
probably
based
know
service.
that the LBS, there's something called push. You know
Mm,
that
yeah.
you basically, when you come close to a certain store, let's say, or maybe some device, then you will start to get alerted. Okay, I mean, this has
Yeah.
sort of been the, I guess, one of the ideas that has been sort of, I mean, stores like to do this, right? They like to send out promotions, right? Discounts if you go nearby, right? So that,
Yeah.
right? So
Yeah.
you could just be going around and checking in, right, and see what are the nearby things, right?
Yeah.
And that could be, kind of a push, right? or you have some like something that you are sending in the vicinity of some area, right?
Yeah.
That would be like a push scenario or this data dissemination scenario,
Mm,
right?
mm,
And then you can and then the people are moving, right? So it's dynamic
yeah.
nodes,
Yeah.
right?
Yeah.
People, vehicles, those are dynamics, right? Devices, equipments, those can be static, right? Um,
Yeah.
right, right, and like managing smart factories, right? That could be both
Yeah.
collection and dissemination. But I guess the point is try to come up real, maybe as real as well as real as possible, and actual problem. The one you described was really good because that was an actual problem
Mm,
that people are trying to solve, right? I
okay.
think if you can describe
Okay.
these actual problems that people are trying to solve, and then sort of
Mm,
pinpoint, yeah, this is a certain type of problem, right?
okay. Okay.
Okay.
Okay.
So I think just
That's
one
what you
at
mean.
the minimum, one in each quadrant. Okay. So the
Mm,
representative. But if you can
okay.
find more, let's say 8, right? That you
Yeah.
have two cases for each quadrant. That
So
would
do you think we even
yeah,
kind of
that
see?
would make the case even more compelling, right?
Exactly.
And
Exactly.
I think it's not just to imagine scenarios. Okay, try to find
Mm,
in literature articles or papers, right?
literature.
Or
Yeah.
yeah, I
Yeah.
mean, or
Yeah.
whatever you come across, like the actual problems that are bothering people. Okay,
Makes sense. Yeah.
you know
Mm,
that
yeah.
relates
I
to
see what you mean.
spatial communication, right?
Yeah.
Okay, this I think will increase the value, okay, and also for your work because then you are whoever reads your work will then start to
Mm,
get a picture, right? And
yes.
they could have this aha moment of saying that, oh yes,
Like,
these are all
oh
valid
yeah.
problems, right? That's
Nice.
like every day. That's just nearby, right?
Yeah.
Um, yeah,
Yeah.
but actually there's some common themes to them, right? And if
Makes
you're
sense.
saying that, right, if you're saying that yes, we are solving all these problems with a unified and simplified framework or a protocol, right, which can also uh,
Mm,
be low cost
yeah.
and scalable because it's decentralized solution, because all these
Yeah.
problems currently have been solved more or less using a centralized approach, right? But I mean, this is maybe the I think the solution part. I think for the problem, let's focus on the problem first. All right, just try to
Okay.
pinpoint like what are the you can describe these, and then I think a separate part to discuss the scaling issues in these problems.
Okay.
Okay, to sort of pinpoint the scaling and cost issues of these
Okay.
problems. Okay, because that will then sort of pave the way
Okay.
to better communicate, why we
Mm,
might need a decentralized solution.
okay. I see what you mean. Okay.
Okay. Yeah.
So problems. Okay. I see. I
Okay.
see. Makes
Actually,
sense.
decentralization sometimes also is good in the even even in some aspects like security concerns. Okay.
Okay.
Like if you are going out through a centralized node, then it's actually a vulnerability, right?
Yeah.
That you could
Yeah.
be like intercepted. Like a lot
Yeah.
of the communications that are secure are basically end to end or peer to peer, right?
Yeah.
So that it doesn't go through like a intermediate, or it's a trying to not uh, that the information be disclosed for any intermediary, right? I mean, but I mean, this is a smaller aspect, but I think focusing on scaling and I guess the cost of effectiveness, I think that's good.
Sorry, I didn't get that last
No,
part.
sorry, I mean the scaling and
Get
cost
it?
efficiency.
Oh yes, yes. That's
Yeah.
like you said. I should put that like in a sort of new or different section.
Right.
Yeah.
Okay, all
Yeah.
right. So does that make sense?
Yes, it
And
does. It makes perfect
okay,
sense.
all right.
All right.
So
But
I guess any questions from you? Victor?
No, I think I get it now. Maybe I don't think maybe I didn't really know that you were talking about yesterday. In my head, I was
Okay,
just thinking
okay,
something.
all right, okay.
I
Yeah,
do understand.
I hope that makes sense. All right. I mean,
It
to
does.
you as
It does.
well. Okay.
It really does.
Because yeah, in many ways you have to sort of understand and see the value of this work, of the
Yeah.
problem, right, that we're solving, and why, again, why is this important? Why should people care, right?
Yeah.
Because if we're just solving this as one of the WSM problems, which many people have done, I don't think we can be better than solving some of the niche problems. You see,
Yeah.
you see what I'm saying?
Yeah.
If this is a particular
Yeah.
scenario case, I'm sure there are very specific solutions that are more practical, cost effective, and all that, right? But then they are addressing a niche problem, and usually it gets more, engineering and technical. Okay.
Okay.
But then
Okay.
it wouldn't be as broad scope. Okay.
Okay. That's
Okay.
fine.
All right. Okay.
Fine. All right.
So is that all right?
Yeah, that's perfect.
Okay.
Thank
All
you
right.
very
Okay. All
much.
right. So that's sync again tomorrow, and I hope to see the
Yes,
problem
8 o'clock.
statement gets
Yes.
written. Okay. All
Yes, no
right.
problem. So tomorrow I might be on the bus at the time, but that's fine.
Okay. Sure.
I'm sure
Sure. Yeah.
I will
Yeah.
still take the
Okay.
meeting,
Yeah.
but
Okay. We'll do a
so
quick
you might
sync then. All right.
no problem. I don't
Okay.
mind even a long one. I'm just
Okay.
warning
Okay.
you so you're not
Okay.
surprised.
Yeah. Sure. Sure. All right. Okay. All right. So talk to you tomorrow then. All right.
All right. Thank
Okay.
you
All
very
right.
much.
Thanks. Thanks, Victor. Yeah. Bye
Okay.
bye. Bye bye.